Yeah, so hi everyone. Let's solve this question that was asked in algorithm design get CSE 2021 set 1. Okay, so what the question is saying, so it is saying that define Rn to be the maximum amount earned by cutting a rod of length 10 meters into one or more pieces of integer length and selling them. Okay, so it is what given, it is given that there is a rod present. Okay, it is having n meter. Okay, and it is saying that we are cutting the rod into one or more pieces. Okay, so maximum how many pieces we can cut the rod into? Maximum we can cut into n pieces. Why? Because we have to cut into pieces of integer length. Okay, pieces of integer length. So maximum we can cut into n pieces, and minimum we can cut into one piece. Okay, why? Because it is saying that we can cut into one and more pieces. Okay, then next it is given that let pi denote the selling price of a rod whose length is I meters. Okay, so after dividing the rod or cutting the rod into several pieces, here there is an array p of, okay, there is an array p which contains the what, which contains the cost of each individual part of the rod. Okay, so let example my rod is of size what, 3. So if I cut my rod into two pieces, one of one length and another of two length. Okay, so p1 means what, p1 means what, p1 is price or cost of rod of length 1, and p2 is what, p2 is price or cost of rod of length equal to 2. Okay, and here it is given the price of each length. Okay, so for length 1 we have cost equal to 1, for length 2 we have cost equal to 5, for length 3 8, and subsequently for each length till 7 we have the cost. Okay, so finally the question is asking which of the following statements is are correct about R7. Okay, so for R7, for R7 there are multiple possibilities, like what, we can do 0 plus 7, or we can do what, 1 plus 6, we can do 1 plus 1 plus 5. Okay, so we will have many possibilities. Okay, so here finding the best solution by the brute force approach will be very much time consuming. So this question can be solved by using dynamic programming. So by looking at the problem statement we can easily find out that we can use bottom up dynamic programming. Okay, and we can write the recurrence relation like that. We can write the recurrence relation like this. Okay, Rn equal to maximum of I from 0 to n what, R n minus I and pi. Okay, so what does this recurrence relation means? So this recurrence relation means that we can take the cost of what, we can take the cost of one length and we will leave the rest of the cost to our algorithm. Okay, so let's understand how this recurrence relation is working by taking an example. So what example we will take, we will take the one that the question is asking. So let example we are taking R7. So R7 will be a what, from I equal to 0 to 1, 0 1 to 0 to n, 3 till n. What we will do, we will have to find the maximum among all of this. Okay, so maximum among what, we will calculate R for I equal to 0, R7 minus 0 and P0. Okay, what does this mean? This means we will take the cost of the rod having length 0 and we will leave the rest for R7. Okay, and what does this means? And for 1 it will be what, R7 minus 1 P1. what does this mean? This means we will take the cost of rod having length 1 and we will leave the rest for R6. Okay, and similarly for 2 it will be R7 minus 2 and P2. For 3 R7 minus 3 P3. Okay, and subsequently like this for n R7 minus 7 P7. Okay, here n is 7. So here what is the last term means? Here we will take the length we will take the cost of rod of length 7 and we will leave the rest for R0 to calculate. Okay, and we will take the maximum of all these available options. Okay, maximum of all these options, and in this process we will have to reuse the values we have already calculated before. Okay, let example for 1 we have calculated like here we can find R6 and we can use the value of R6 in other options calculation also. That's why it is a DP problem. Okay, yeah. So and as we are solving it using bottom up approach, first we will have to calculate R1. Okay, then we will calculate R2 and here we will use the value of R1. So how to calculate R1? For solving R1 we will use this recurrence relation. Okay, we will use this recurrence relation. So what will happen from maximum of 0 to 0 less than I less than 1. Okay, R n minus I P I. Okay, so it will be what? Maximum of what? R1 minus first we will do for 0 0 P0. Okay, and R1 minus here I will be what? 1 P1. Okay, so we will have to calculate the maximum of these two, then this will be assigned to R1. So what does these two options mean? These two options, the first one means that we will first take the rod of length 0, the cost of rod of length 0, then we will leave the rest up to R1. Okay, the second one means what? We will use the cost of rod having length 1 first, then we will leave the rest up to R0, and after calculating the maximum profit for R1 we can use this value in the calculation of R2. So that's why this is a bottom up approach for dynamic programming. So but this process is bit lengthy, that's why we cannot use this process in a real gate exam. So that's why we have to see the options here. So that's why checking manually for each options one by one will be a easier one for us in the gate exam. Okay, so if we look here we can observe that there are only 3 options which will give us the maximum result. Okay, and there are P7, P6 plus P1, and third one is P2 plus P3 plus P2. Okay, this will be 18 here. Okay, this will also P6 is what? 17 plus 1 equal to 18, and this will also give us the value 18. So if we see that, or if we observe that doing or solving it using the traditional approach taking us long time, then we can shift to the manual approach which will be very fast rather than solving it using traditional approach. Okay, so let's see the options. So option 1 is R7 equal to 18. So yeah, it is the true statement, because here we can see that 18 is the maximum cost that we can come up with. Okay, and R7 will be 19. This is wrong. Option C is R7 is achieved by 3 different solutions. Yeah, so as you can see here, the R7 is achieved using these 3 solutions. Okay, so this statement is also correct. And for option D, R7 cannot be achieved by a solution consisting of 3 pieces. So this statement is false. Why? Because here in the last statement, the last option we can see that we can find the cost as 18 by using the length of 2 twice and length of three ones. Okay, so here only option A and option C are correct. Yeah. So yeah, thank you so much for watching.